Hello everybody, my name is Manuel La Rosa Betancourt. I am the CEO and co-founder of Neutron Star Systems, Dissemination and Exploitation Partner at MEESST, a consortium project funded by the European Innovation Council within the Pathfinder project. Today I'm here with Dr. Jan Thoemel, head of the Cubesat Laboratory at Luxembourg University. Jan, thank you very much for receiving us today. Can you please tell us a little bit more about yourself and the work that the university is doing?
Sure, thank you, Manuel. Yes, I started my career at the von Karman Institute, a partner in the MEESST project, so I belong to the family.
Of hypersonics?
Yeah, the hypersonics family, yes. Then I joined here 5 years ago at the university and started, among other things, the space competence,
Right.
which is very, very ambitious and fastly growing.
What are the areas where the university is operating? What topics is the university covering?
So the most important legacy competence is the satellite communication. It started from the need of satellite communication for the biggest operator at the time, satellite operator, the SAS. Those colleagues said, do the most advanced satellite communication research there is in the world. Today they use an enormous amount of artificial intelligence for signal processing, for planning of beams to reach customers. It is just amazing what they do. Another one is robotics. We have a laboratory that simulates the surface of the moon, where we have surface robots. Another laboratory where we can simulate the orbital robotics. For example, if you want to assemble very big structures in space, you need to understand well how the objects move in zero gravity.
So the university is doing also research on this area, building robots and also writing software to control and work with robots.
Exactly. The robot as such is already a complex piece of technology, but what receives a lot of progress recently is the software, how to operate with, how it perceives the environment, how it can move autonomous environment. This has a lot of potential for space application, even for terrestrial applications, and this is what my colleagues here make big leaps forward. And then here in this laboratory we research system engineering, satellites, how to build them better, faster, cheaper. For example, we use small vacuum chambers that do not have the same kind of vacuum that we have in space, but it suffices, and you can see already how it's standing here. We can do ultra fast developments here, or in other facilities we simulate the Earth magnetic field, which is very important for navigation and altitude control purposes, and we can develop these satellites in a very, very fast way.
Thank you very much. In another matter, can you tell us a little bit more of the role of the university within the MEESST project? And tell us, is there a team working on it? I mean, what is your particular role within the project?
Well, because I started my career with a PhD in hypersonics and all these physics effects that remained in my heart, and I desired to continue it. And I had actually written an initial version of the simulation code that we use for blackout prediction here in MEESST, but I wasn't happy with it. I knew it's not accurate. And then when the consortium contacted me if I can join it, I was very, very happy. It was the opportunity that I was hoping for to improve that code.
Is this a code that you use for simulating the signal propagation of the communications?
Indeed. What we know is from experience, for example from Mars missions Beagle 2, that we want to have a communication during these very critical phases of re-entry. The Mars capsule re-entries goes through what is called the 7 minutes of terror, very harsh environment, and it loses the capability to communicate, and we want to overcome it. It's super, super important.
I'm really interested to see how that work has been performed within the project. So can you tell us a little bit more about what is the concrete role that Luxembourg University is having within the MEESST project?
So we improved that tool, we call it BORAT. to implement some advanced satellite communication aspects. Things that actually I don't know very well because I didn't study this, but here at the university we found the experts that we needed. So we asked our colleagues from the satellite communication group, CCOM, can they help us? We bring in the plasma knowledge, they bring in the satellite communication knowledge, and then we marry this to get the most advanced simulation code available in the world. And then we recruited a PhD student, Johannes, and he took on this challenge, and he's working tirelessly to improve that simulation code so that in the future we do not lose communication during blackout anymore.
Interesting. So Johannes is working on improving the code to simulate the communication signals that are going to be taking place within a plasma environment.
Absolutely.
Am I understanding right?
Absolutely. And this is highly complex because not so many people understand plasma and the signal propagation. But it's more complex than that. Not only do we want to understand how signals propagate in plasma, no, within MEESST we use strong magnetic field produced by superconducting magnets to modify, manipulate the plasma, and possibly punch a hole into the plasma and then to enable the communication. And so it's the interaction between satellite communication, signal processing, plasma, and now very, very strong magnetic field. That is, the physics are very complicated, and that we try here to understand and then to predict how we can modify the blackout.
Thank you very much. So you are working with a team in the university to do that?
So we are a small team here. I'm leading this from the hypersonic side. We have colleagues who will help us with the satellite communication aspect, and Johannes, he takes all this advice and improves the code. We're a small, efficient code. We're a small and efficient team within the large MEESST consortium.
Thank you very much. I look forward to then try to speak with Johannes in order to learn a little bit more of the details of this improvement work that you're doing in the Borax software.
He's the expert. You should indeed talk to him.
Thank you very much.